Assalamualaikum and good evening. We are from Group 3. We will present the experiment 7, which is the estimation of heat capacity and entropy generation. Specific heat capacity is defined as the amount of heat energy required to raise the temperature of 1 kilogram of matter by 1 degree Celsius. Below figure is the comparison of specific heat capacity for a big and small mass. The heat needed to transfer to a small mass is lower compared to a big mass. So that is why the specific heat capacity of small mass is lower to a big mass. This is because the specific heat capacity depends on the mass and composition, which is in the specific heat capacity mass graph, the line shows it is directly proportional. For entropy, it is a measure of the molecular disorder or randomness of a system. The concept of entropy provides the deep insight into the direction of spontaneous change for many everyday phenomena. The entropy used to describe the behavior of a system in terms of thermodynamic properties, such as the temperature, pressure, entropy, and heat capacity. The figure shows the application of entropy in our daily life, such as the ice melting process, where the entropy increases from solid to liquid because of the randomness is higher for liquid state compared to solid state. The total value of entropy must be positive value since the reaction is exothermic. The objective of this experiment is to estimate the heat capacity of different metals provided and to estimate the entropy generated when these metals are dropped in a container containing palm oil. There are 3 scopes for this experiment. The first one is the coverage of this study is the different metals used, which are aluminium, copper, and steel, and also the substance used, which is the palm oil. Second, the study consists of the temperature increase until 80 degrees Celsius as final temperature when the palm oil is heated. Third, the study covers the temperature change for every 1 minute. For in equilibrium condition, both metal and liquid has the same temperature until the temperature starts to drop. That means the net heat transfer from metal to palm oil is equal to 0.
Next, I will talk about theory. Specific heat capacity is the quantity of heat required to raise temperature of 1 kg of sample by 1 Kelvin. They can be calculated using the formula Q equals to mc delta T. According to the first law of thermodynamics, internal energy of the system is plus or minus work done on the system with the energy transfer into or out of the system. In order to conserve the energy, in this experiment, we consider it is adiabatic process. No heat is lost to the surrounding. Since all the heat lost by hot metal will be absorbed by palm oil, the energy of metal is equals to the energy of palm oil. Specific heat capacity of palm oil at room temperature and pressure is 1.861 kilojoule per kg dot Kelvin. Before drop in the temperature, uh, they will reach equilibrium position where T2 of metal is equals to T2 of palm oil. In this experiment, we will calculate specific heat capacity of each metal. So theoretical value that we supposed to get is for aluminium is 0.89, copper is 0.385, and steel is 0.466 kilojoule per kg Kelvin. According to second law of thermodynamics, a process must always occur in the direction of increasing entropy, which is entropy generation must be equals to or more than 0, because process can occur in a certain direction only, not in any direction. So in this experiment, the direction of process is heat energy is transferred from high temperature body to low temperature body. Entropy can be calculated using the formula mCp ln T2 over T1, and total entropy is calculated by adding entropy of metal with entropy of palm oil. Second law of thermodynamics can be proven from the calculation of entropy generated. When entropy generated is more than 0, it is irreversible process. When equals to 0 is reversible process, and when less than 0 It is an impossible process.
For the experiment setup. So this is our experiment setup. So first we have two retort stand, two thermometer that scales between -10 degrees Celsius to 150 degrees Celsius, and then a palm oil in 100 ml in beaker 1, a hot plate magnetic stirrer, an electronic balance, palm oil in 100 ml beaker number 2 that are covered with aluminum sheet, metal that contain that are copper, steel, aluminum, and stopwatch. Next for the methodology. So step one is to weight all metal, aluminum, copper, steel using the electronic scale and record the weight. So step two is to record and weight all the empty beaker using the electronic scale. Next, we move on to step 3. So step 3 is 50 milliliter of palm oil is poured into two beaker. And then after we pour palm oil into the beaker, we weight the two filled beaker using the electronic scale. So step 5 is a sheet of aluminium is wrapped around one beaker and covered with aluminium sheet. Then copper metal is placed into the beaker. The beaker that is not covered with aluminium sheet. So step 7 is to heat the beaker until the temperature reaches 80 degrees Celsius. And then next step is to immediately after the temperature reaches 80 degrees Celsius, immediately the copper is transferred to the beaker that is wrapped with aluminum sheets that contains the palm oil. Step 9 is to for every 1 minute, the reading of the thermometer is recorded until the temperature drops or remains constant. That means no change. So the last step is to repeat step 6 to 9 by replacing copper with steel and aluminum metal.
Results and discussion. Specific heat capacity of palm oil CP is 1.861 kJ per kg Kelvin. First, mass of copper is measured. Mass of palm oil is mass of beaker 1 with palm oil minus mass of beaker 1 without palm oil. Temperature of palm oil in beaker 1 is measured and recorded. The same steps are repeated in measuring aluminum and steel metal. Table 1 shows temperature recorded every 1 minute for copper, aluminum, and steel. The equilibrium temperature of copper is 36 degrees Celsius, aluminum is 39 degrees Celsius, and steel is 43 degrees Celsius respectively. This is the example calculation of copper metal. Heat loss by the copper metal is equals to heat gain by the palm oil. Q copper metal equals to Q palm oil. By substituting mass of copper, initial and final temperature of copper, mass of palm oil, specific heat capacity of palm oil, initial and final temperature of copper, we will get the value of specific heat capacity of copper is 0.2698 kJ per kg Kelvin. Next, calculating the entropy change of copper and palm oil. Entropy change of copper equals to mass of copper times specific heat capacity of copper times ln final temperature divided by initial temperature of copper. We will get the entropy change of copper is negative 0.00142 kJ per Kelvin. Entropy change of palm oil equals to mass of palm oil times its specific heat capacity of palm oil times ln bracket final temperature divide initial temperature of palm oil, we will get entropy change of palm oil is positive 0.001533 kilojoule per Kelvin. The entropy change, lastly, the total entropy generated is equals to entropy change of copper plus entropy change of palm oil equals to positive 0.000113 kilojoule per Kelvin. The same step also repeated in calculating the specific heat capacity, entropy change, and total entropy generated in aluminum and steel, respectively. The table 2 shows the summary calculation of specific heat capacity, entropy change of metal, entropy change of palm oil, and total entropy generated of copper, aluminum, and steel, respectively. Metals used in this experiment are copper, aluminum, and steel. Percentage of deviation is calculated to compare the experimental specific heat capacity with its theoretical value shown in Table 3. Graph 1 shows graph of different metals versus experimental and theoretical value of specific heat capacity. Based on the graph, the experimental specific heat capacity of aluminum and steel is higher than theoretical specific heat capacity. In contrast, theoretical specific heat capacity of copper is higher than its experimental. From the experiment, the value of total entropy generated for copper is positive 0.00011 kilojoule per Kelvin. Aluminum is positive 0.0001513 kilojoule per Kelvin, and steel is positive 0.000381 kilojoule per Kelvin. For all three materials, the total entropy generated value is more than zero, which is the positive value. It proves that the process is irreversible reaction. For entropy change of metal show negative value due to heat loss. Heat loss causes temperature decrease, kinetic decreases. The degree of disorder of metal atom also decreases. Lastly, the entropy of metal decreases. For entropy change of palm oil shown positive value because heat is lost by metal absorbed by palm oil. Temperature of palm oil increases, kinetic energy increases, degree of disorder of palm oil molecule increases, and entropy palm oil also increases.
So sources of error and the method to minimize the error. So from table 3, there will be a slight difference between experimental and theoretical value of specific heat capacity, which are in the range of 71.75% to 29.92%. So the experimental value is different from the theoretical value due to some unavoidable errors that may have occurred during our experiment. While the errors which might have occurred and the method to minimize is the first one is the thermometer might have touched the wall of the beaker or the bottom of the beaker. Thus, before placing the thermometer, observe the tip of the thermometer to ensure it does not touch any part of the beaker. Second is the parallax error, where readings were taken when eyes are not positioned perpendicular to the measurements, marking which cause inaccurate reading of thermometer. Therefore, we must place a ruler to observe the value more accurately. And the last one is random error. Random error is where environmental factor due to the air movement and not turning off the fan in the lab will resulting in more heat loss from the system to the surroundings. Therefore, before the experiment, we must turn off the fan, close the window to reduce heat loss to the surrounding in order to get more accurate data.
Justification on the importance of stirring the palm oil in the beaker. Stirring is important because it helps to mix the palm oil and ensure the temperature throughout the palm oil is always constant. Stirring helps to mix the palm oil so that no area in the solution is hotter or colder than other areas. Therefore, heat can be distributed evenly in the beaker and give a more accurate reading of thermometer. Justification on the importance of transfer the hot metal quickly into the palm oil. Is it very important to transfer the hot metal quickly into the palm oil in order to minimize any heat loss to the surrounding and to get a more accurate data of specific heat capacity? CP of metals. The metals have a higher density and higher energy than air, and hence some energy from the metals will be lost to the air through conduction. This will cause a laser energy from the metal released to the palm oil and hence cannot get an accurate CP value of metals. Therefore, the hot metal needs to transfer quickly into the palm oil to ensure that the whole energy from metals can be released into the palm oil to get an accurate CP value. Okay, for the conclusion, this experiment is considered success as the objectives of this experiment are achieved. From the experiment, heat capacity obtained through this method is equal to 0.29269 kilojoule per kilogram Kelvin for copper, 1.048 kilojoule per kilogram Kelvin for aluminium, and 0.5729 kilojoule per kilogram Kelvin for steel. We can see that the heat capacity of aluminium obtained from this experiment is higher compared to copper and steel. After calculating the percentage error of these three metals, it shows that the percentage error of specific heat capacity for copper, aluminum, and steel are 29.2%, 17.75%, and 22.94% respectively. We can say that each metal has a high difference between theoretical and experimental value of heat capacity due to some errors. As for the entropy, the value of total entropy generated is equal to 0.00011 kilojoule per Kelvin for copper, 0.0001513 kilojoule per Kelvin for aluminium, and 0.0000381 kilojoule per Kelvin for steel. We can observe that the value for total entropy generated for each metal are greater than zero, which proves that the process is irreversible. For the safety and laboratory safety, for the laboratory safety, wear appropriate personal protective equipment, including lab coats, gloves, and closed-toe shoes to protect against hazardous material like heavy weight might fall on our food or corrosive material that might harm our skin. Tie back long hair and avoid wearing loose clothing and jewelry that could cause in equipment. For the precaution steps, take the measurement reading with your eyes perpendicular to the thermometer to minimize parallax error. Do not touch hot beaker or hot plate magnetic stirrer with bare hands. Instead, use gloves. Handle the thermometer gently as to avoid thermometer from breaking and leakage of mercury, as mercury is toxic to human beings. For the references, This is the reference that we study to make our report. That's all from us. Thank you very much.